Just in case I'm not the co-host, so I have no control over recording.
Yeah, it's okay. I'm doing it.
Okay, yeah.
I'll do it, no problem. So, very good morning to you. And regarding this question, which was asked that this output, this factor analysis output, which I received, please bear in mind that a few things we should be very clear that when we do the linear regression, multiple linear regression, we may get intrigued that is it so that this is not the final analytical tool which shows the cause and effect relationship in the most optimum manner? Can we have something better? Can we have some more rigorous technique? Yes, we can. We can apply them, but that doesn't guarantee that the results would be even better. It's absolutely no guarantee, right? So that way you can apply the other analytical test. For example, we did this principal component analysis, which is a part of the factor analysis. The question is, then should you even do it? Imagine a situation that you have done the linear regression and then you want to apply some more rigorous technique and you apply it. And you find that the results are not so different or not so good than what you could have got in the linear regression. I would say that still show them, because we have a word, robustness, checks of robustness, checks of robustness. In simple words, the meaning of robustness in research is that it's like saying that Stefan does something and he comes to me and he said, Shab, I have done this thing and this is the result. And I say, Stefan, with due regards, I trust you, but can you bring some witnesses with you who have seen you doing this thing? And then he finds some people who saw him and who can vouch on behalf of him, that say that, yes, we saw it. It's a genuine thing. This is called test of robustness or checks of robustness. So if you have done the linear regression, you have some outcomes, you have the outputs, you have the tables and everything. But then on top of that, if you want to have the reassurance, double check, then it's not a bad idea to have another tool of analysis, but basically doing the same job. In the linear regression, whether we have the simple linear regression, two variables, one dependent, one independent, or if we have the multiple linear regression, or one dependent and many independent variables, they are underlying the cause and effect relationship. And by the way, factor analysis is also doing the same cause and effect analysis. So technically, there's not much difference between the two, but it's another test to which we can put under the label. So when you are writing in your thesis, your chapter 4 is usually called findings or results, right? And in the chapter 4, we have 4.1 something descriptive statistics. Then 4.2 we have, for example, correlational analysis. 4.3 is the inferential analysis, basically cause and effect. You can also have 4.4 robustness checks, or tests of robustness. You can see the exact spelling in the chat. And then you can have another analysis, like, for example, I saw in case of Yarko yesterday about this PCA, principal component analysis, and that also you can say apply there. Yeah, make sense?
Yeah, it makes sense. Like, really, the biggest biggest reason like I emailed you about it was there like any like critical mistakes in its face that I had made there?
Oh, no. I think everything was fine. There was no mistakes. Everything was fine. But at the same time, when you shared this finding with me, I was kind of intrigued. And I was asking myself that, hey, why don't we have this culture of test of robustness? So why not we have this? Because usually in the high class, in the top literature, in the top level articles, the publishers insist that don't show me your conclusions based on one set of analytical tools, apply multiple analytical tools. And then some publishers or some journals, they really insist, or rather they appreciate if you have applied some test of robustness. So it's a good idea that we should also, not in every case, I'm not giving any dictate now. I'm just saying that when and where it's possible, it's not a bad idea to apply robustness check. And Yarko, in your case, it works perfectly well. I think it's a good idea that you go ahead with the robustness checks.
Yeah, okay, that's cool.
Yeah. The second thing which I want to discuss with you, especially our presenters and the conference presenters, is that let's book the meetings. Let's fix a deadline, because remember that 15th is a deadline. It's a final. Nothing would happen after 15th regarding the conference. This, your submission of your working paper or your article. Please book individual meetings with me between, I would say that between, I know I'm meeting some people on Friday, but try that we meet at least on Monday to Wednesday. My Tuesday is booked, but if possible, try to finalize kind of your working draft by this weekend, so that we can have some preliminary meeting on Monday and Wednesday. Because remember that there might be many other checks. I trust you guys that you'll be doing everything fine, but still the language, the paragraph indenting, where to kind of shuffle the text and all that stuff. So that might be requiring my suggestions to you, because after all, it'll be published. So just imagine that your article is published in this book and there are some spelling, there's some typos. It's not a good idea, So let's do this thing and focus not on the contents part much, but rather we focus more on this layout, the display, what you call them, the writing instructions, the template, which I have by the way provided to you in my previous email. I send the template to you. So let's do this thing. It could be possible that in some of your cases, I have to meet you twice before you submit it finally. So find me. If you want, I can book already a session, let's say of 2 hours or 3 hours, and then at least 2 of you can come and discuss. Daniil, I'm meeting you Friday, right?
Yes, of course.
But then I have to check with the Yarko.
Really depends on what my boss says. It's heavily dependent on that.
Okay. Well, you have your day job, right?
Yes, I have my day job, yeah.
But we can meet in the evening. I mean, Monday evening is possible. We can meet.
If it's cool for you, then yeah, I'm down. Actually, hold on. Hold that thought. Is Wednesday evening actually better, or is it too late?
Wednesday would be.
Actually, no. Let's go back. Let's do Monday evening.
Wednesday would be 11th.
Yeah, but Monday is good. I just make my stuff work by then.
So
yeah.
So now we have Daniil is sorted. So Yarko, we can book a meeting with Yarko. Stefan, can you also come?
Yeah, of course.
So yeah. And how about you, Tatiana? Can you?
Yeah, I will.
Okay.
I'll try to. Yeah.
Should we meet in the campus?
Yeah, we can. Yeah, sure.
Or
Cool.
Yarko, do you want to see online? How you think is a good idea?
I'm cool. I should be able to make it.
Okay. So because now it's an important thing, so I think we should meet here and but I can still record because whatever I say about your work, I will be recording it so that it stays in the records, and just in case you have to refresh or rewind, it's fine. All right, so we will have a meeting soon.
Yeah, cool.
So I write down Monday evening Yarko meeting. All right, so let's go to the next technique or tool which I want to discuss with you. Yeah, another tool which, if you allow me very quickly, I have so many windows which I want to shut down. This sometimes really slow down the. Yeah, okay, let's see how it goes. Yeah. All right, I share my screen with you, and we now have the data spaces. Okay. Another technique or the tool which you can consider applying is called yeah, so it's like a general linear model is something which we can also consider general linear model GLM technique, which technically is once again the real base, the real background of this concept is still regression, but this is more rigorous in the sense that there are many potential issues which are ordinary least square regression has, which can be overcome by the general linear model. And which are those? Remember, we discussed some of the problems that we have yesterday. We came across this autocorrelation, that the multicollinearity, when there's too much of correlation between the independent variables and the impact on the dependent variable is somewhat harmed or hampered. There can be one more violation which can happen in the ordinary least square or the normal regression model, is that, let me quickly share with you this limitation. That limitation is that the standard deviation of the error term, remember I showed you the error term yesterday? We assume ideally in the perfect world, the standard deviation of the error term, who we call as a disturbance term, and there's one more name also. What was the name? Which Daniil mentioned yesterday. Yeah, so that standard deviation may not be constant, may not be constant. It means that the variability of the error term could be fluctuating. And if that is fluctuating, then the reliability of your coefficients of regression can be harmed. But if we apply the general linear model rather than the ordinary least square model, then those problems are by default taken care of. Because in theory, the general linear model is already is constructed in a way that your standard deviation of the error term can never fluctuate. It always sticks, and it always sticks to 1. There is number 1 which it sticks to always. This is the beauty of the general linear model. But otherwise, the basic premise of the model is same, what we do in case of linear regression. Okay, so there's nothing different except the fact that the general linear model is kind of more foolproof when it comes to the assumptions of the theoretical assumptions of the linear this regression, the cause and effect theory. That is the only advantage we have. And once again, if you want, you may consider it as a robustness test. So never, please mark my words, never think that the PCA, the principal component analysis that we discussed yesterday, and this GLM, which we do now, are the substitute of your multiple linear regression. No, they're not substitute. They are rather complementary. Okay, so they are just showing another level of analysis, but otherwise they're not replacing the usual regression that you do. So please mark my words carefully. How we do it? Well, it's not a problem. We do it. We have the data here, the same data that we picked yesterday. Once again, we go to analyze, and here we go to the general linear model, and we pick univariate. My suggestion is that always pick univariate. And we have the debt to equity ratio as a dependent variable. And then remember, we have the log value of the total, I think it was total revenue, then the operating profits, return on capital employed, annualized firm stock return, FTSE 100, annualized log of market cap, price to earning, median board size, education, experience. If you look at the shape and the nature of these variables, they're fine. None of them is an absolute variable. So the size effect has been taken care of already. And these we use as the covariates. And the model that we use, first we use the full factorial model, then the contrasts. There's no need to plot. There's no need to plot anything. And then is there any EM means? No, I don't see anything which we need to change, save. We're not going to save any. We already have the, and by the way, if you want, you can have the, the word which I was asking for as a substitute to the disturbance term or the error term is called residual. Residual. And remember that we had yesterday also. Since we have it yesterday, so I don't want to put them again. So there's nothing. And then if I click OK, then you can, sorry, I need to do it again. I think I forgot something to click. So we have the general linear model. We have univariate model. Did I put the plot save? Oh, my apology. I didn't put the coefficients, options. There we go. Yeah. So this I forgot, because otherwise we will not have the regression coefficients. So we need to have the descriptive statistics. If you want, we have the estimates of effect size, observed power, and the parameters. Remember, the most important are parameters. The most important are parameters, because parameters are basically your regression coefficients. Parameters estimates are the same, which we call as a regression coefficients in the linear regression. And then we can test for the heteroscedasticity. This can be a problem. I don't want to go, because you guys don't know. I wish we have a course called Fundamentals of Econometrics. I would love to teach it. But otherwise, heteroscedasticity is the same problem, which I told you that sometimes the standard deviation of the error term is not constant. If it is constant, then we call it homoscedasticity. It's a very difficult word to say. Homoscedasticity, which means same. But if your standard deviation is changing, then homo turns to hetero. And then we call it heteroscedasticity. Okay, say 10 times, you will have your pronunciation power will definitely improve. And then nothing else we need. Maybe significance level we can make from 5 to 1. 1 means 10. I mean, 0.1 means 10. That is the only thing you need to do. And where is the OK thing? Because continue. And once we have them, we click OK. And now we can have the, now we have the values. You can see the parameters here. And once again, the B, huh?
We don't see the result.
You don't see it? Oh, okay, I do. I'm sorry. I just do it. I click and I share the output now. Does it show?
No, again, the data view. We only see the data.
Okay. Share screen, and where is the output? Ah, here is the output. Yeah. So this is how the only table which you need to check is the parameter estimates, and you can see that these are the betas, the same betas which we saw in the linear regression, and the same sig that we see in case of linear regression. But the only reason why we do it is that this is more likely to overcome the potential violation, theoretical violation, which the linear regression may end up doing, and we may not be even aware of it. So this is more, you can have a sigh of relief. Oh yes, with this we are able to overcome whatever conceptual problems, especially the one which is the heteroscedasticity, which basically means that there's a danger that your standard deviation of the error term may not remain constant. So that limitation can be overcome by this general linear model. And here you can see that we have log revenue is significant. Yeah, sign is negative, of course, that's a different thing. It means basically mean that we can say almost 100% confidence that the total revenue, the companies whose revenue is more, they have lesser debt for the given equity. Same is with the operating profit return. So two accounting variables, operating profit returns and the natural log of total revenue are telling the same thing, that if you are doing fantastic accounting performance, then your debt to equity ratio is small, or rather goes down, change other way around. And then we have the return on capital employed, which is again, I think it looks that and then there is so I think there are many things which looks better now. Yeah, so similarly, the market performance works opposite. So the companies which do much better market performance, stock market performance, they borrow more. However, if there is by the way, yesterday, this FTSE return was a significant variable in the linear regression, but now it has become insignificant. And then all of the corporate governance variables are not so significant, not at all, except for the education. So the educated, if your board size, if the median board size is more educated, they pick up less debt for the given. So higher the education at the board level, lower is the debt, the borrowing for the given amount of equity. So some results are same, but it could be possible that we might have some contrasting signs as well, or some could be insignificant in the linear regression, but they can become significant here and vice versa. So please be prepared for these. So then the question is that, just imagine if there's a variable which has been significant in the linear regression and also in the general linear regression model, then the robustness shows that, hey, we have tested with 2 techniques and the results are same. Not only they're significant, but even the sign is same. You know, if it is positive, it's positive. But if it happened that even though in both techniques the result is significant, but once it's positive significant and the other time it's negative significant, or it's possible that something was insignificant in the linear regression model, but it becomes significant here, and vice versa, then when we make the discussion and we make some conclusion, then we should not give very big statement, or we shouldn't give a very sweeping statement. Then we should say with the caution that even though the phenomena exist, but the robustness test do not support it fully. So say, give a conclusion based on the linear regression model, but little bit with skepticism, with some disclaimer. If your results are not matching in the linear model and in the general linear regression model. So in that case, your conclusion, your inference should be a little bit more mild, more mellow, more with a disclaimer. But if it happened that in both tools and in both with the original test and with the robustness test, you have the same finding, then your confidence should be bolstered even more. It should be even higher, and you should be making more conclusive remarks. But if it doesn't, then you should be a little bit careful, or a little bit more, more realist while making some conclusion. Yeah, make sense? Yes or no? Okay, so you can see that there's not real big difference between the two. And now we move on. If you have any questions, but it seems that you don't have. Right. And now I can take you quickly to the data once again. And now the last thing, which I do it now, I was thinking that I would discuss more techniques with you, but I think if the need be, we can have a new set of sessions in the near future, because I don't want to load you with tons of new things. So the one last thing which I want to discuss today is called binary logistic regression. The binary logistic regression is that, let me teach you the theory a little bit. Share screen, whiteboard, and we take the text. The next one, and I take the text instead. You know that this is the linear regression, or should I even draw it instead of, yeah, drawing is better. You know that, what is this? Yeah, this one. You know that this is your regression model, alpha plus beta x plus, let's say there's only simple linear model. And then we have the error term or the disturbance term here. Please give me some examples of the dependent variable. Can somebody give me some examples of some dependent variables?
Stock return.
Sorry?
Stock return.
Stock return. Is stock return quantitative variable?
Of course.
Okay. So give me some more examples. when we say that y depends on x?
Qualitative or quantitative?
Well, you can give quantitative first if you want.
GDP, let's say.
GDP, quantitative. Now, wait a sec. What if your dependent variable is qualitative? Qualitative variable could be when you have yes or no. Or more specifically, the qualitative variable in this case, when I say yes or no, we call it binary variable. Binary means 1, yes, 0, no. Binary is also called dichotomous. Dichotomous. So there is a dichotomy between 1 and 0. Dichotomous. Sometimes we also call it categorical, but categorical can be multiple categories. And in this case, I'm only focusing on 2 categories, yes or no. A phenomenon exists or it doesn't exist. If I say that the probability that the fact that a company commits default or not default depends upon its performance. So can I say in theory that the companies whose performance, the stock market or accounting, whatever, the company whose performance is great, really good, have less chance to make a default? Or can I say that the gender of criminal depends on the income class he or she comes from? So we can also make a theory that those families who are very affluent, very rich, very well off, the chance that somebody in that family is going to make it, the chance that certain gender of the family makes a crime is low. Do you get my point? So when we have our dependent variable, or can we say that the companies, let's say we want to say that the companies who are older are less innovative. And how we measure the innovativeness? With a binary variable. Well, we can measure innovativeness in many ways. We can measure them in the quantitative way. Like, for example, if you see the income statement, we can find R&D expenses divided by the total revenue. Or if you want to check from the balance sheet, you can also see the intangible assets to the total assets, or change in intangible assets to change in total assets. There are many ways to quantify it, but we can also measure qualitatively the forward-lookingness of the company, the innovativeness of the company by the binary variable, yes or no. Yes, this company is innovative, this company is not innovative. And this you can decide on the basis of some benchmark. You can categorize the company, that any company which has innovated or which has introduced 3 products last year, you will call it innovative, and the one who has not will be called not innovative. So then those who have launched 3 or more products, you put sign 1, this value 1, and the one who doesn't, you put the value 0. So there are many ways. There are many examples in which you can have a dependent variable which is qualitative by nature. And believe me, if you have such variable 1, 0, 1, 0, though your y variable, then your linear regression doesn't work. Or it shouldn't work. Well, it can work if you force in SPSS to do it, but the results can be very kind of shoddy. They will not be good. they will not be reliable. So in this case, we have to slightly change our technique, but there's a minor tweak, nothing else. I would say that the 99 point things do not change, just extra tool you have to learn. But please, 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 mark my words. The binary, what do you call it, this binary, this dichotomous variable, we only use a technique we only use if your dependent variable is a binary variable. For example, if I measure the company's innovativeness by the R&D expenses to the sales revenue ratio, then I will not use the binary regression model. I will not use it, and I will apply simple, our usual least square regression model, but not in this case. If there's gender 1, 0, if it is a categorical default, not default, successful, if you want to make some variable called, okay, the one who fulfills these conditions, we call it successful, and the one who doesn't, we call it unsuccessful, 1 and 0. So if we have this kind of situation, then we apply the binary regression model. Okay, so very quickly, I show you something. I hope you can see my screen now. And you can see that today, as against yesterday, I introduced a new variable, one extra variable. It's called innovativeness. Here. And here, because it's based on, what's this boy's name? Ilya, when he did his research.
Yeah.
So this is based on one research that we did some years ago. And we made this categorical variables that, okay, certain company we call innovative, and certain companies we don't call innovative based on some criteria. And you can see that there is a variable 1, 1, 1, 1, 0, 0, 0. So there are variables which are innovative, 1, and the one who are not innovative, we call them zeros. So it's like a dichotomous categorical variables. All right, so we want to see that which factors make a company innovative or not. So basically in this particular example, if I share my screen with you, the whiteboard, then I would say that on what factors innovativeness depends. So I would say that the innovativeness depends on, well, I'm taking all other variables which I took yesterday. The first category of variable was some revenue and operating profit and those kind of things. So I can call it accounting performance. Accounting performance. And if you recall the same data that we studied yesterday and even today, the second set we had was some stock market performance. Stock market performance. And the third set of variable that we had yesterday and even today was the corporate governance variables. So we can say that the innovativeness of the company depends upon how well the company has been doing in terms of its KPI, the accounting KPI, and then how well it is doing in the stock market. And thirdly, what type of leadership it has. So we can say that those board where the level of education, experience, expertise is high, the theory would say that they would be more innovative, and those companies where the board of directors education expertise are low, perhaps they would be less innovative. And let's assume that we are able to form our hypothesis. But here you can see that the innovativeness is measured not in the quantitative terms, but in the qualitative terms, 1 and 0. Okay, and then we go back to the data. And here is the data. Okay, so we go to analyze as usual, and then we go to regression, which we have already, and you can see that we have the binary logistics. So this is our main, this is the starting point. We go to analyze, we stick in regression, but within regression, we have the possibility to pick up binary logistics. So we take them And then we have the dialog box. I already did. So you can see that I put innovativeness as the variable here. Yeah. And then all of the variables I put in the, let me do it again, because then maybe you will not realize how it works. So let me do it again. So we have the, so as we did before, so we pick the variable and we call it dependent. And all of the variables, which include the accounting and the stock market and the corporate governance, we can put them here in the dialog box. And do we make any new categories? No, there's no need. Continue. Do we have anything to save? Well, we can save the, yeah, I think we need to save the probabilities. That could be useful. And do we have any options? Of course, we have the options. Yeah, this we need to pick up. This shows the quality of your score. And this is fine, and the style, nothing else. And then we click OK. Yeah, and you can see that we have quite a big data, and we have the yeah. So you can see that we have the classification table. So there are.
We don't see it.
Huh?
We don't
Oh,
see
sorry.
it.
Sorry. I do it now. This is always So there are overall 50.3% of the sample companies. So you can see that 0 and 1. These are the values we took. There are 50.3% companies which are innovative. And if you want to find the ratio of innovativeness and the non-innovativeness, you can just divide 75 by 7. So this 1.0014 is basically 75 divided by 74 exponent, So this 1 point, you can relate this 75 divided by 74 is basically 1.004. And then we go straight away to the last section. Yeah, I think all our models are fine. Significance is okay. Everything is good. And then here we see, now it looks like the regression output. And here the beta, the unstandardized beta, which we need. And then here we have the significance. So here you can see that the company's operating profit return, look at the significance level, 0.74. So I can say with approximately 93% of confidence, sign is positive, that the companies whose operating profit return is up, is high, are more innovative. Isn't fantastic?
Yeah.
This we can't find with the linear regression, because if a dependent variable is, binary, then we can't do it.
Yeah.
And here we can say 67.3 return on capital employed doesn't make a company innovative or not. Annualized stock return, it's below 10%. Yeah. So the company who are, but the sign is negative, by the way. So here the interpretation is that we can say with 92% of confidence that the companies who perform good in the stock market are bad in the innovativeness. Again, we have to justify the result, but
Yeah.
And then the stock market index doesn't make any company innovative. And then we have, look at the massive amount of value, but that doesn't make any sense. 100% confidence that the companies who are bigger in the stock market, listed exchange, they are bad when it comes to innovativeness. So we make a conclusion that the smaller companies, the companies which are small, seems to be more innovative. Look, the companies which have higher market capitalization are doing bad in the innovativeness. So it means that the companies which are small are doing more innovativeness. And similarly, the education. Look at this. Education makes the companies less innovative. Maybe their education is very theoretical or not, they don't see the, but it's very interesting finding, isn't it? That you can say about 96% of confidence that people, the board of directors whose level of education is up, they are less innovative. And experience, capital structure, it makes no difference on the company being innovative or not. So this is the beauty of this whole concept, that you can do almost same thing which you are able to do with a linear regression, but you don't come across those problems of linear regression, because here your dependent variable is not quantitative but qualitative, and that too not even qualitative, because you can say 5 categories. For example, there are many surveys when you tick the box and you say 5 is strongly agree, 4 is kind of agree, 3 is average, 2 is disagree, 1 is strongly disagree, 0 is no response, nothing, you know. So in those kind of researchers also, this binary logistic regression is very, very useful. But in this example, I strongly took 2 extreme categories, yes, no type of thing. So in that case, we are able to find the results, but without going through the problems that we can go through in the. So for example, if you're in the real research, your dependent variable is qualitative, then this binary logistic regression is not a robustness test. Then this becomes the main test, because then you can't apply linear regression at all. Okay. So here is a word of caution that you can't compare this results with the linear regression result, because in case your qualitative variable is your dependent variable, then the only choice is this type of regression.
So can I ask if we have a non-binary variable,
non-binary
for
qualitative
example,
variable,
qualitative type,
then you can create categories.
but it's called binary logistic.
Huh?
This model is called binary logistic.
Yeah, but then you can say that even though it's binary, but we can make categories.
Yeah.
Look, if you strongly agree, then you only fall in one category, number 5. If you say that, no, I don't know, I have no opinion, then let's say you are 0. Then you stick to that category. So then it's like a yes and no. So if your yes is 0, then all others are no, basically.
Yeah.
You can't be in 2 categories. So when you pick up one category, even though you have more than 2 categories, then basically is that you stick with one and all others are no.
Yeah.
So that somewhat is close to the binary, not strictly, but you can make some tweak.
Yeah.
But I would say that whenever you have some qualitative variable in the form of dependent variable, then go with this. Yeah, usually this technique is more suitable when you have a primary data collected based on some questionnaires. You know, sometimes you do the quantitative research, but not based on secondary data, but based on the primary research, and you send some survey and you ask people to tick the box, male, female, and rural background, city background, educated, uneducated. Your company has been given some warning by the regulator or not, this kind of thing. So 101. So when you have this type of thing, then this is a very good technique. But I think the probability that anyone will be using it in a student is very low, because most of you get the secondary data. But as I said, this boy who I named before, he experimented a little bit that if we can also, so if we take innovativeness in the quantitative terms, but if we also take in the qualitative terms, like 1, 0, 1, 0, does it make a difference? Okay, so that's it for today. So, and once I get the video, then I will be sharing it with you. Please let me know if you have any questions.
Shab, may you pause please the recording? I would like to show you some results of my general linear model results.
Oh my goodness. Okay, please go ahead.
So may I show them?
I think you need to pause the recording.
You want me to pause the recording or should I continue recording?
Maybe, yeah.
Record or no record?
No.
Okay. Oh.